shit.
That's what I'm talking about.
Wait! Okay, now, from the beginning.
All right, I'm gonna go ahead and get started. So thank you for showing up. I know it's super early. See a couple familiar faces, so glad to see you're here for the other side. I was doing some AR core workshops earlier, but today we're gonna be talking about ARKit. So out of curiosity, how many people have tried out ARKit before? A few people, that's good. So my name is Dan Miller. I work for Unity Technologies as an XR evangelist. Means I focus a lot on augmented and virtual reality, building a lot of sample applications, giving workshops, traveling around, kind of doing community outreach. If you guys have any questions about what I'm talking about here, general Unity stuff, AR or VR, feel free to reach out to me. That is my email, and I do have some business cards as well, if you guys are interested in that after. All right, so let's go ahead and get started. So what I'm gonna do today is give kind of a high-level overview of how ARKit works. Having an understanding of how it works will help you kind of better develop apps and things like that for it. Next, I'm going to talk about some of the core features, going into some of the 1.5 beta features, which are out now. There's no kind of planned release date for that, but if you are in the developer program, you can get the beta, you can try those out. Next, I'm just going to talk about some kind of tips and considerations for developing, things you can take advantage of that we provide, things you can kind of build on yourself. Give a brief overview of face tracking. So that's part of the ARKit SDK that's included if you have an iPhone 10. And then I'm just gonna kind of blast through some demos that I've created and give some examples of what some other people have created. And then I'm gonna try to break down those demos, walking through the explanation of the kind of technical implementation of what's happening, so you guys get a little better understanding of that. And I'm happy to share anything after. If you guys want the slides or something like that, just feel free to email me. All right, how does it work? So ARKit is using something called visual inertial odometry. And at a high level, what it's doing is it's using computer vision on the device, so the device's camera, and it's using IMU data from the device. So these are things like the accelerometer and the gyroscope. So a lot of people come up to me and ask, how come ARKit came out so quickly after it was released into like the public, and how come AR Core kind of was more delayed? And one of the main reasons for that is that Apple has had a very strong influence or kind of total control over their manufacturing process for their devices for a very long time. So IMU sensors, things like accelerometers and gyroscopes, are very twitchy, and kind of the data that you get from them can be very noisy. But because Apple has calibrated those sensors in their manufacturing labs, it's easier to kind of reach a broader scale of devices where they kind of control all of the manufacturing there. On the Android side of things, you have, Android phone development happens all over the world. It's a much larger scope, so it's kind of taken a little bit longer to calibrate those devices and kind of get there early for the manufacturing. So the core features at a high level are plane finding. So right now the base is horizontal only. In the beta there is vertical. Positional tracking. So this is basically when you found a plane, you can kind of move around in space and the device knows the rotation and position that you're in. And light estimation. So this is being able to basically kind of understand what you're looking at in the frame and either shade or light your models based on that. And there's some additional information from there. So I'm just going to kind of go over this. So for plane finding, it's using feature points, which are kind of interesting points that the computer vision algorithm recognizes. And then from there, when it finds about 3 or 4, it'll go ahead and create a plane. The way the plane finding works is that if there are planes that are kind of overlapping or it understands them to be the same, they just kind of merge together and create a larger plane. Right now, again, in the release features, planes can only be kind of square or rectangular. Next, they have hit testing. So in ARKit, when you're gonna basically place objects in the world, you need to kind of have a special raycast from the device into the real world. And what they've done is they've provided this for casting against things like feature points, which would be much quicker than kind of waiting to find a plane. And what you can do with this is, again, it's kind of just this built-in raycast function if you're familiar with those inside Unity, but they've built a special one to kind of do it into the world and then also pinpoint on these key feature points there. Next, we have light estimation. Here's some pieces of pizza that I've placed in the office here. And you can see that when I move the device over here, which is kind of darker frame, that it's actually adjusting the light of the of the scene here. And the way that this is working inside ARKit is that there's a special script attached to a real-time directional light, and it's actually just modifying the intensity value. So when it gets a little bit darker from the ambient value there, then it's going to kind of turn down the intensity. Also, ARKit now has an ambient color temperature. So if you were out in, let's say, the desert, and there's lots of orange and things like that, you can actually use that color value to kind of modify the directional light as well. So you could, again, light your objects a little bit more like the real world. All right, so now we can go into some beta features. So in beta, they do have vertical planes. This has been a kind of hot feature that everyone really wants. The one thing to note is, similar to the horizontal planes, you still need kind of interesting feature points. If I were to try to get vertical planes on this white wall right here, I would have a really tough time. Maybe if I was able to kind of notice this stuff or notice something over here, there's some more interesting things going on that wall, but in general, you have to be a little bit careful because the plane finding is all determined by feature points. For this one is a kind of painting in my apartment, and it was able to find it based on kind of the noise that's going on inside of that painting there. Next are irregular planes. So what this does is this actually kind of goes and builds up a mesh based on what you're looking. So you can do things like circular tables. Here I'm just doing it on top of my bed, but you can see that it's not necessarily exactly square, and so there's a couple parameters that you can modify for either tiling the texture in here, which happens to just be the Unity cube, as well as the outline. So it kind of gives you an outline and then builds up planes from there. You can use it just like the other planes, but now you can kind of detect and track different surfaces and things like that. Last is image anchors. So this is a big one as well. If you're doing any sort of calibration, or if you're kind of aligning yourself to something, you can actually upload your own custom image anchors. It does need to be built into the app. So I know some people are trying to kind of do it at runtime, and I've been having some difficulties with that. So basically what you can do is you can take almost any picture. Some are going to be a little bit easier to detect than others, but from there you can basically get an anchor to that. So it's like a key position. If you move it around, it can kind of re-find it, but it's not going to track it as well as maybe some other AR SDKs you might be familiar with, something like Vuforia. But this is kind of super helpful. There's a couple more features that I'm not highlighting here in the beta. A big one is being able to kind of redeclare your origin. So the way that ARKit works inside Unity is that when you start the application, you are positioned at 0, 0, 0. That's kind of the origin inside the Unity scene. As you move around, as you kind of navigate in the world, you go from that origin. So if you were to create something that kind of tracked your motion path, right now you would have to kind of start it at the bottom, then you would lift your device up to be that 1.5 meters or however tall you are. But with the ability to reset your world origin, combined with these image anchors, you can really kind of set your origin to be a known spot. So if you're kind of, you have something on the ground there, you say reset world origin to that position, then that's how you can kind of extrapolate from where you are. All right, some tips and considerations. So use tracking states. There's basically, ARKit kind of has a session here. You can link into the session at any point and get back kind of useful flags based on what's happening. These are things like insufficient features, if you're looking at something like the white wall. There's also excessive motion and things like that. Really, with AR being as new as it is now, I think it's important to kind of onboard and have any of your users, if you're kind of producing an app for consumers, to really understand what's going on. If they're on, let's say, the train or the subway, and they open up their app and they're not tracking and they don't know what's happening, it's going to be a bad time. The other thing is the kind of ideal motion for finding planes and detecting them, and that is kind of more of a like circular or a back and forth motion from there. So again, linking in with this, providing some UI, kind of instructing the user how to calibrate and find planes is always an important thing to consider. The next thing is, I've talked a little bit about feature points. I've described what planes are. For attaching things to objects quickly, it's much more kind of optimal or a better user experience if instead of using planes, you're using feature points. So if I were to make an app that was measuring the height of this podium here, it would be difficult. It wouldn't be impossible, but it would kind of take a long time to find a plane on top here of the here, cast a little anchor here or something, then find a plane on the ground and kind of measure that distance. If I'm using feature points, I can just find something that's interesting and happening here, say, hey, here's the start of it, go down to the bottom, and then say, hey, there's the end. So instead of waiting for planes, you can just cast against feature points, and that's how you can, just quickly get objects in the world, and those do have kind of a position in the world. So definitely consider that. You can kind of disable and reset the AR session inside your app. If things aren't working or something like that, you can kind of prompt that, which will go ahead and restart it there. And you can also limit what you're looking for. If you're only doing feature points and you don't want to find planes, like that measuring app, you can kind of restrict that inside the initialization of the session. So consider doing that. With all the data that's going in from the IMU and the computer vision, it can kind of be fairly intensive depending on what device you have. So the more you're restricting or not doing can be helpful there. All right, this is a huge one for me. Use shadows. So, in the real world, almost everything has shadows, or cast shadows, I guess. And inside ARKit, what we've done in our plugin is we've included a special shader that allows for shadows on transparent objects. So what you can do there is you can actually just create a plane. So you can see me moving the plane there. This is just a 3D plane primitive. I've included that special shader, and then there's a real-time directional light that's actually casting shadows. So what you can do is if you're placing objects in the world, you can basically just have this be a child object kind of at the base of your object, and that'll cast shadows. Something I've done as well in the past to make, as good of I don't want to say viral videos, but make interesting ARKit videos, is you can actually go and adjust the rotation of a directional light inside your app to match what the shadows are looking like in real life. So I live here in San Francisco. There is a Jewish museum around the corner that has a massive open courtyard. That's where I shoot all my AR videos because it has some kind of interesting floor there, and there's usually not people hanging out. And a couple of videos I've done, I went out there. I was kind of seeing what's going on. I was seeing the angle and direction that people's shadows were being cast at. And then I went in and kind of modified the rotation of my directional light. Now, it might be a little better to have that ability to rotate that in your app, but it really adds a lot to the experience and really kind of places objects in the world there when you have realistic shadows. And you can see here with the plane there, we're getting kind of the accurate kind of angles with that little checkerboard cube, and then the circle as well. So definitely keep that in mind. And one thing I want to note as well is that this shader happens to be included in the ARKit SDK, but there's nothing that's restricting it to the iOS environment or anything like that. So if you were using other mobile AR SDKs, you can go ahead and just grab this from here. It's just a special shader. All right, next thing is using real-world size. So the way that Unity works for virtual and augmented reality is that the size you author things at is the size that it'll be in the real world. So Unity has this idea of a kind of plane primitive that is a kind of, or a cube that's like a 1 meter by 1 meter cube. If I were to create that inside Unity, place it here in the world, that's going to be kind of 1 meter high. So when you're creating things like digital characters or environments, kind of keep that in mind, that the scale that you're authoring it in Unity is going to be relative to the real world scale. All right. Next thing is just kind of think about object interaction. So a lot of the times in ARKit, you're going to be placing objects on a plane. You might want to kind of move objects around on the plane. No thanks, Tunnel Brick. You might want to move objects around on the plane, but most of the time you just want to move it in kind of the X and Z direction. So if you've placed something on the plane here, you want to move it around in this direction. If you start to move things below in the Y direction, then it's kind of going to be clipping through the world. And the way that the rendering works in AR is that the digital objects get rendered last and on top of the camera feed. So that's something to really consider there is when you're placing objects, if you can place them as close to the floor or on the floor as possible, and if they start to clip through, you're gonna get some kind of weird perspective or rendering issues that are hard to kind of understand. All right, so that was a lot of information. What is next? Oh, whoop, whoop. All right, so ARKit remote. Basically, I'm gonna be using this a little bit with the face tracking. What we've done is we've provided a one-way stream to Unity where you can actually hook up an iOS device and you can start to use it to collect ARKit data and debug and kind of build on top of some of your devices there. So I definitely recommend checking this out. You'll see how you can utilize it for some more interesting features here in a moment when I go through some of my demos here. But basically, the general idea is that there's a special scene inside Unity. You build that to your device, you launch that, and then when you run the editor with the device plugged in, you can kind of hook it up through the console and start streaming the data there. All right, face tracking. So this is, as you might be aware, this is an iPhone X only feature. It's using the front-facing camera, which has some kind of depth sensors and things like that. But the high-level features here are a face anchor. So this basically is kind of at the center of your head or face, and this is tracked. One thing to note here is that this is inside your face. So when you're going to kind of line up objects, if you put it right where the origin is, then I'm going to have like a mustache kind of coming out over here or something odd like that. So definitely keep that in mind. I will say the ARKit remote is super helpful for iterating on a lot of the face tracking stuff. Just because you can start to understand scale, line things up, and then kind of copy those component transforms, apply those back. Next thing is facial mesh geometry. So actually it's able to scan your face and mesh that at runtime. And what you can do with that is you can apply another shader. So I talked about the shadow shader. There's also an occlusion shader. And what you can do with that is it basically occludes any geometry that is kind of shown on your face. So I have an app where I'm kind of wearing a hat. Well, I want to kind of tip the hat back a little bit because that's how people normally wear hats. Well, with the way that rendering works without this occlusion shader, you're going to kind of see the back of my hat through or on top of my head. If I put the occlusion shader on the mask, you'll see that it actually kind of clips and looks like it fits around my head a little bit more. So that's just something to kind of keep in mind. But again, we're getting kind of real world meshing geometry on your face at runtime. Next thing is facial blend shapes. So there's actually 50 coefficients, which you can think of as kind of just floating point values that are being kind of read and manipulated from your face. These are everything from the movement of your eyes to how much your kind of left lip is open and things like that. And so what you can do is you can go and create digital characters, and you don't have to use all 50 of these coefficients. I will say, if you find an artist that's making facial blend shapes and has all 50 of these, that is can be a somewhat daunting task. But you can actually just use a couple of them. You can use mouth open, you can use left eye, you can use eye opens and things like that. And we do actually include a sample that does have all 50 if you guys want to check out how that works. And I'll be showing that here in a little bit. But the other thing you can do with these facial blend shapes is you can actually link into just one of these and then drive interesting kind of interactions and things from those. And I'll be showing a little demo of that. All right, here's a visualization. This is Jimmy, if you guys don't know. He is kind of the core developer behind ARKit from our side. So you can see here the image anchor. You can see how it is kind of inside of his face. So it's kind of the origin there. Here we have the real-time meshing and the blend shapes over there. Just gotta give a shout out to Jimmy. All right, demos. What is the first one? Spaceship. So what I'm going to do here is this one is going to kind of demonstrate. Let's see what we got here. This one is going to demonstrate, sweet, how the kind of motion tracking works. So the first thing I'm going to do is I'm going to grab this piece of paper, put it on the ground over there so I can hopefully find, oh, see, and I found a plane right away. That's perfect. So what I'm going to do here is I'm going to try to, something there. And so what I'm doing now, it's a little bit hard to see, but I have started a kind of timeline animation that has a spaceship coming down from the heavens there. So what I've done is spawn the spaceship. There's some basic controls to kind of spin it around. And it'll go and find the door here, right there. And now I can open the door. And because I've placed this in the world and kind of locked it in here, I can now just go and kind of walk inside of it. So this is this motion tracking that I'm talking about. You can maybe look out at the window, see some of the beautiful audience there. But you can see I can kind of just walk around in it. Now there's kind of a thing in the center there. But again, I've placed just an object in the world. The size of this object can be kind of determined how you want, but you can see how you can start to either interact, walk through kind of digital or virtual things. Again, this because this is kind of rendering on top, it's kind of going through the table and things like that. But in a more open environment, it might look a little bit better there. But you can see, again, like I've established a ground plane, and now as I move through the world with the accelerometer and gyroscope, it's able to just kind of manipulate through there. So again, there's not much code going on here at all. I just spawn a really big object that happens to have some geometry on the center, and then you're able to just walk through it once you've placed it on a ground plane there. All right. Portal. All right, so this one, if I remember which one it is, here we go. Whoop. Little teaser, it's what's coming next. All right, so this one is basically a portal effect. So it's fairly common. I've seen a lot of these, especially when ARKit first came out, kind of showing off basically a portal into a different world or something like that. And the interesting thing here is that as I move around, I'm actually getting kind of a different perspective into the portal. So you can see I'm kind of, if I want to like look at that tree, I'm just moving around here. And the way I'm doing that is basically using something in Unity called a render texture. And I'm going to walk through how I kind of set that up inside the Unity editor here to just explain how that works so you guys could potentially build something like this. Now, right now, it's just kind of a viewing portal. But you can imagine that once I got close, because I know the position of the camera and the position of that object inside Unity, I could then kind of trigger a different effect. Maybe I could go into the portal, maybe I could teleport to it, something like that. All right, so how does this work in Unity? There's all my cool apps there. So let's go, not this one, this one. All right, so what I'm doing inside Unity is I'm basically, right here, I have my little portal. You guys can see this. Let me make this a little bit bigger. So I have my little portal here, and the way that it's set up is that it has a just cylinder that I've kind of mashed together, and it's using this shader, and the shader is being supplied by a render texture. So what a render texture is it's a way to take what a camera is rendering, instead of having that camera render, say, hey, everything you're rendering from that camera, put in this texture. So this is just kind of a special object inside Unity. You see I have it over here called Portal RT. And what I have set up inside Unity is I have a portal cam. So this is just a camera that's actually located over here looking at this little environment. And what I'm doing code-wise is I'm taking my main camera, which is hanging out over here. This is what's driven by the AR device. So this camera, which is the main camera that has this Unity AR video script on it, this is what's rendering the real world. This is what's moving around. This is what's tracking. So what I'm doing here, in order to get that kind of perspective on the portal, is I have a little script right here that basically says, let's see, I don't know how to make this bigger, unfortunately. Oh, there we go, figured it out. So what I have here is I have a little script that basically says, hey, have a public transform of the real camera, and then basically have an offset that's like 100 units off, and this one happens to be 100 units off in the X direction. And in my Unity scene, I've put this little object here 100 units over there. So then what's happening with this script here is that I'm saying, hey, basically have the same position and rotation, but with the position have it offset 100 units. So that's where I'm able to kind of use the rotation of my device to then drive this other camera that's over there. Do you have a question?
Yeah, so can the main camera turn to see the reference scene that's being lit onto the
So potentially, but you can set up calling flags on the main camera so that so not be rendered it. Yeah, that's a good question there. So potentially, if I looked over there or if I walked 100 meters, I would be able to see that. But you could also kind of offset that 100 meters as well, and it could be past the clipping plane there. But again, I'm just basically have two cameras like this. Everything's happening with the rotation, and then the position is just offset, and that's what gives you that little perspective and depth on the portal. All right, Anim Recorder. So this is very hot off the press, as in I made it a few days ago, and the demo has worked in the past, has been a little finicky, so you guys are in for a treat, but I want to walk through it at a technical level before I attempt to do it. So this is the sloth. This is now kind of the Unity Animoji that ships with the ARKit plugin. So this is able to use the front-facing camera to drive all these blend shapes. So if I go ahead and look at this sloth here, you can see that if I go into my inspector, which I can put down here, you can see that he has a bunch of different blend shapes. If I kind of modify one of these blend shapes, you can see his eye kind of moving there. Maybe we could do something like eye squint, and you can kind of see it. So again, these are fairly subtle blend shapes that you can kind of manipulate here, like that. So you can see it kind of blinking there. And these are all driven by that front-facing camera. So what I'm doing in this demo here is I'm going to use the ARKit remote and my iPhone X here to record some facial captured animation. And then inside Unity, I'm using an experimental animation API that allows me to record data that's happening in the Unity editor to an animation clip. So this is going to be me capturing my face, doing some stuff, and then it's going to be recorded as kind of offline facial capture that we can then play back as an animation inside of Unity. So let's give it a go. So I'm going to unplug this, plug in my camera here. There we go. Some nice pictures of me and my grandpa. So now I want to go to here. Let's see if this works. Daniel's iPhone. All right, there we go. Here's my apps. So I'm going to basically launch something called ARKit Remote. This is something I've pre-built to the device through here. And now inside Unity, I go and I hit play. And then I link up my device through the console here. So you can see iPhone there, and then I start tracking on here. So you'll see it hopefully go there. So that's me in the editor. Let me zoom out a little bit. So this is me kind of driving the sloth's face. And now in the game here, I can go ahead and hit the space bar and say like, welcome to GDC. Ah. So it's a little bit delayed. But now I've kind of hit space there and stopped recording it. And now if we unplay it here, you might have noticed that it does kind of tilt to an angle there, unfortunately, with the motion there. For what was happening on my device, it's just a camera feed to me. This is kind of how the remote works once you've allowed it to do that and allowed face tracking. But back in the editor here, what we can go and see is with my animation clips, I've now recorded the position. So this is me kind of subtly moving around. It does kind of, again, rotate there. But I've also recorded the blend shape values. So this is all the blend shape values. There's tons of like kind of subtleties that's going on. But you can see as I kind of scrub through these, it allows me to play those back. And you can see I'm looking pretty happy right there, even though it's so early in the morning. So what I can do now is I can go back and you can see all these values that have been changed. So I'm kind of locked on the animator there. I can go back here and I've already created a couple animator components that have references to these clips that I've just captured. So I'm going to kind of turn that on. So in the inspector, I want to turn that on, and then I want to also turn, this one's already on. So now I'm just going to go ahead and hit play in here, and we should be able to see, there we go. So we're seeing kind of the playback of what I was saying there in the editor. So I've kind of captured myself doing some facial capture, and then you could imagine using this on like an NPC or a character or something like that. So again, on the technical side, just to show you guys how that works, I hit up the animation team last night. I was like, hey guys, why is this recorder still experimental? And they basically said they've been really busy with other stuff, including a lot of the GDC stuff, and they haven't fully tested it, but they are expecting it to kind of come out soon. So for these scripts here, I just want to show you here real quick what you can do. I'm going to open up this one. What you do for, all right, that was not the IDE I expected, but we can roll with it. What I'm doing here is, let me see if I can make this bigger. Here we go. I'm using, again, this experimental animations API, the namespace here. This recording only works in the editor, so that is something to keep in mind. But if you are processing or able to pass through information through things like the remote, you can go ahead and use this. And then what you do is you just create a game object recorder and kind of create it, a new instance of it here, set its root to the object it's on, and then you specifically bind a component. So if you're familiar with Unity and how the animation system works, what you do is if you hit kind of the record button, and then any value that you change on that object is going to get keyed into the animation clip. So if I'm going kind of in here, and just to kind of show you guys this real quick. So I have a cube right here. If I go in my animation window and just create something real quick like this, if I hit the record button right here, and then I start manipulating this cube, you can see that these values over here have now turned red, and down here we now have a key there. So that's kind of how the animation system works. It's kind of like I'm activating this record button. So in the script here, what I'm doing is you bind a certain component. And this could really be any component that can be keyable or animatable. And for this one, I'm using the skinned mesh renderer. That's where all the blend shapes live underneath. I'm saying, this is the object, and I believe this is a callback to if it's taking objects underneath it. And then what I'm doing here is I'm just saying if the clip's equal to null, return. If I am recording, then I'm going to be taking a snapshot at time.delta time, which is just the rate at which time is passing. And then if I'm stopped recording there, we're going to save it to the clip. And so in Unity, I have a animation clip that I've assigned here. So let me go to my sloth head. And so you can see there's this little face clip down here. So yeah, I just wanted to, how do I, yeah. So anyway, so you basically what you do is you just create a public clip, and then all your values get kind of outputted into that using this game object recorder. And you can, again, kind of use this for multiple things to process and kind of turn into animation clips. And then once it's an animation clip, you can use that in a state machine. I could record the welcome to GDC clip. I could record the have a good morning clip or whatever, and then just use that in a state machine or something like that. Question?
Are the keys editable or the curves on these?
Yeah, so the way the animation system works, we have this here. Let me.
So the recorded stuff is editable?
Yep, so this is the dope sheet, and here are the curves. You can see because we're just using just kind of set values here. But yeah, we could go and kind of grab these and move these around. So yep, these are just kind of keyed properties there inside of Unity. All right, so next one, face stuff. All right, what do I mean by this? We'll find out. So let me go back and see if we can get this going. All right, so this one I believe is like this. And so what I'm doing here is a couple different things. So I'm linking into a single blend shape that is the mouth movement here. I'm also including an occlusion mask on my face. So if you notice that if I hold my mouth down, it looks like it's kind of being clipped by my lips. So you can see that. So it's kind of really coming from my mouth, I guess. And what that does is that's just a kind of subtle touch that you could do that makes it, again, occlude objects behind your face. And then I'm just linking into a blend shape, turning on a particle effect, turning off a particle effect based on the value of that blend shape. Question?
So the occlusion masks, are they limited to the front-facing camera at this point in time?
No, the occlusion shader can be applied to anything. There is an example where we have the occlusion shader on planes. So you could place an object. If I found a plane on here and I placed an object there, and I kind of pull my camera back over here, it will be occluded.
Would that work for the rear-facing cameras in ARKit?
That's what I'm saying. Yes, you can use it. It's just a shader that you can use on anything. And it just occludes any objects behind it.
As long as it can detect the plane.
Yes. So like that's the thing. You could potentially do something where you're spawning like little occlusion cubes on feature points or something like that. But it would be better or probably a little more optimal if you put it on the plane. You detect a plane here, you put an object over there, and then you get that occlusion. All right, let's go ahead and try something else out here. All right, so this is what I was talking about here. This is Cowboy Dan. And what you can see here is that I'm using the occlusion mask to, again, kind of restrict what's happening over here in my hat. Because typically everything just renders on top of the camera feed. You know, I can't put my hand in front of my mustache here because all digital objects get rendered on top. So by using the occlusion mask, I can more accurately kind of place objects like this and make it look like they're kind of on my head a little bit more. All right, and this might be the broken version. This might not even work. Yeah, so here's what I'm talking about. So this is not using the occlusion mask. And that's because all digital objects are rendered on last, and you can see that there's nothing to kind of pull my face out there because this is just happening on top. And so this is what we get without using the occlusion mask or without using the facial geometry here. And these are just child objects of the anchor that's found on my face there. All right, that's what I wanted to show there.
I'm sorry, I don't mean to interrupt. Is there a Brianna here? No. All right, thank you.
All right, next thing I want to show is this is my coworker John. He is based out of Australia, and he is the evangelist there. He's done a lot of AR work before joining Unity, and now he's doing a lot of kind of cool experiments in what's going on here. So what he's doing in this example, and it's a little bit blurry, I apologize for that, is it is taking an image of the camera, what you're getting from the camera feed, and it is then wrapping it in a cube map that you can then reference for reflections. So what you can see here is that this is Kyle the robot. He's really shiny. As he walks by this person wearing red, there's actually a red reflection on Kyle. So this is, again, kind of like real-time reflections that you're able to apply to objects based on what you're seeing. Now, typically a cube map is going to be 6 pictures all around you. So I'd take one here, take one here, take one here, take one here, things like that. Unfortunately, you know, this is kind of a little bit fuzzy because you're only getting one angle. But if you wrap it in a cube map, do a little bit of blurring, things like that, you can get some pretty cool effects here where the real world is affecting these digital objects. And a big part of any augmented experiences is how much you understand about the real world. So taking advantage of things like environmental lighting, taking advantage of things like real world shadows and stuff like that. You know, the understanding of the environment, the better you understand it, the better you're able to kind of augment objects into the real world and create some kind of cool effects where the real world is actually interacting with those objects. Question?
Are you casting a shadow there with the light from the top, or is that baked?
On Kyle?
Yeah, on the floor, you can see the shadow.
Yeah, I think that would be, that looks like it might be a real light. Yeah, just kind of subtle there. So yeah, this is really cool. When he was showing this off, people people's minds were pretty blown. And then just in general, it's kind of cool with AR objects or just AR apps in general. I really like the ability to implement things like screen capture, so you can like share stuff to social media. So when we were doing this, it was at a conference in India. We were going around. A lot of kids were kind of posing with Kyle here, and he kind of played some looping animations and things like that. And then we would send the video or the picture to them. So if you're interested in this, he has implemented it for ARCore and ARKit. There's plans to potentially wrap it up into some of our higher level APIs for the multi-platform stuff, but it is available on his GitHub right there. It's just github.com/JohnSietsema/AR camera lighting. And so he does have to do some slightly different things with the way that we're kind of capturing and rendering the real world or the camera feed for each mobile SDK. But this one, I believe, was captured in ARKit. All right, that's it. Thanks a lot for coming. If you guys have any more questions or things like that, I'll be around. I think we have about 10 minutes left. And if you guys have any follow-ups or things like that, feel free to shoot me an email. That's my Twitter, where I post a lot of AR and random Unity-related things. So thanks a lot for coming. Yep.
So for like the shadows, you were saying when you go over by the Jewish Museum that you would like figure out the shadows ahead of time and then build it into the app. Is there a way that ARKit can detect that, or is there something we could build into it? You were saying you could change it.
Yeah, so basically the inside Unity, the way the direction of the shadows are controlled by the rotation of the directional light. So potentially you could have like a little gizmo in your app that is just adjusting the rotation through that. Right now, there's nothing. There's no API to detect where lights are coming from. I know it's something that a lot of people want, and I imagine they could be working on something like that, because that again just goes a lot further into matching these digital objects into the real world. Cool. Any other questions? All right. Yep.
Sorry, one more. Again, with the shadows, so say, well, I guess, does ARKit have a way to sort of anchor something in mid-space? Does it always have to be? So say, like, I target the table,
Yep.
but I want something to be floating up here,
Sure.
and then, so I would tap there and then go up there, and you place the shadow plane where you tap,
Yep.
and it doesn't matter how high it is?
No, I mean, what you're going to run into there is things like quality settings on mobile, and then just, just kind of shadow distances and things like that. So yeah, you could definitely, and what I do a lot, I didn't really mention this, but in all AR SDKs and ARKit specifically, when you're placing objects on planes, it's actually placed from the root of the object. So if I had a character right here, and his root happened to be maybe here, like in the center, if you place that on the plane, he's going to be halfway in the ground. So you always want to make sure that you either kind of have a parent root that is at his feet, so that you place him there. And then for like a floating object, again, you would just put the root of the object with that shadow plane at the base there, and then you could put, whatever you want, any amount of distance above that. All right, thanks a lot, guys. Hope you enjoy the rest of your GDC, and thanks for coming.